back from the break. Let's get started. The last thing that I would like to show you before we do a little bit of theory again is accessing the dashboard. Now this step really depends on, which cloud you're in. So if you use an Azure cloud or Google cloud and a Kubernetes cluster there, you will have to do different steps. The following demo is specific for our school's Kubernetes cluster, okay? The first thing, if you want to follow along, that you need to do is you need to make sure that the kubectl proxy still runs. We need the proxy. And then, if you take a look in my slides on slide 9, you can get a URL. We will take a look at this URL in a second and dissect it and paste it into the browser. And with that, you should see the Kubernetes token. You have to sign in with the token that you get either by using the kubectl command that I showed you before, or you just log in at cloud HTL Leonding @CRT. Go to login, go to dashboard, go to dashboard, and then you get this login token, you see it here, and then you put this login token exactly here. Sign in, and that will give you your dashboard. The only thing that you need to do is you need to switch to student or Stropek or of course your system, and then you can interactively, graphically take a look at what's going on in your Kubernetes cluster. So if you are tired of typing in kubectl statements, you can use the dashboard. What do you have to change here? Let me zoom in and show you how this URL looks like. You see, this URL uses the local proxy. It references the so-called dashboard. See that one? And the only thing that you have to change is you have to change the namespace. Yes, question. The only problem that you have here is that the dashboard does not automatically at the first sign in recognize your namespace. But what I did, I ignored the bug and simply entered my namespace. And therefore I didn't have to reload it. So Professor Aberger is perfectly correct. He gave you a simplified answer to make it simple for you, but technically just the namespace is missing. Type in the namespace and you're good. Okay? Okay. Good. So this is the dashboard. Hey, if you love the console, if you love to type kubectl, then you can ignore the dashboard. But sometimes the dashboard comes in really handy. Dashboard is available nearly everywhere. So you can run it in your Azure cloud, you can run it on your Docker desktop, you can run the dashboard anywhere. And now you learned how to access the dashboard using kubectl directly for our school's Kubernetes cluster. Nice. Good. I like that. Now let's make a little bit more theory. Not too much. We will dive into demos in a second. But we need a little bit of theory in order to understand what's going on behind the scenes. I call it Kubernetes 101. First, the first important term is pod. If you want to learn more, you can also follow the URL that is behind this link. I told you already, pod is like a container. A container can have sidecars, so theoretically it's possible to run multiple containers in a single pod. Nothing special, just remember the term pod. Now it's getting more interesting. Pods can have associated services. Services gives the pods stable IP addresses. So the pods become available for external access. There are different types of services. There is the so-called node port service. Node port means that your pod is accessible on any machines of the cluster over the same port. So even if your pod runs on machine A and you are accessing machine C, Kubernetes will redirect the traffic to the pod running on the different compute cluster, on the different compute node. Understand what I mean? That is called a node pod. A service type load balancer is a more complicated one. This is thought for complex non-HTTP APIs, complex workloads where you want to make a service available from outside. We will not talk about load balancers here. If you want to know more about it, you go here to load balancer and learn more about it. But generally, the service is making the pods available on the network. This is what a service is. The next important thing is a replica set. You typically don't define replica set directly, but you use so-called deployments. But just to describe what a replica set is, a replica set is a single pod with a number of desired replicas. You can say, give me this pod, but with 5 instances. And the feature that you have 5 instances is part of the replica set. Got it? If one of those machines die and you suddenly only have 3, the replica set, the replica controller will make sure that another 2 instances are spun up again. This is a replica set. The deployment is sitting on top of the replica set that makes the replica set really important, because the deployment adds so-called rolling updates. What is a rolling update? Please try to follow me, because that is important. In your diploma thesis, if you use the Leo Cloud or any other Kubernetes cluster, deployments is what you are going to use. Deployments mean that you have multiple instances of your pod running, and if you want to deploy a new version of your API, for instance, Kubernetes will make sure that not all of your pods are stopped, so your application is no longer accessible, then updated, and then spun up again. But it will do a rolling update. It will take the first one, pull it down, update it, then it will take the next one, pull it down, update it, then it will take the next one, pull it down, update it. So it's like a wave running through all your replicas, and it updates one after the other. It's a little bit simplified because you can define a lot of rules. If you have thousands of instances of your pod running, it will not take one pod after the other. It will take maybe a set of 100, pull them down, update them, and run them again. Technically, they are not updated. Just a new pod is spun up. Understood what I mean? So deployments is pods plus replica sets plus rolling updates. And this is exactly what you want in a modern software architecture. Deployments is one of the Kubernetes objects that you most frequently will use. And there are many other workloads which we will not take a look at. Just to quickly mention them, for instance, a cron job is important. That means that you have a certain job that should run on a schedule every 5 minutes, every day at 2 o'clock in the morning. You can define that as a cron job, for instance. Okay, nice. Now we have talked about pods, about services, about replica sets, and about deployments. Now we have to talk about how they work together, because it works completely different as you might be used to from traditional networking. Let me ask you a question. If you have 2 services outside of Kubernetes and one service would like to talk to the other service, how does one service communicate with the other? Well, over the TCP/IP. And how do they find each other? Either through a DNS name or through an IP address, correct? So you have a direct connection. This service says, I want to talk to the service that lives at this IP address at this port, correct? Kubernetes works differently. Kubernetes assigns every object in Kubernetes a collection of keys and values, key value pairs. Let's call them tags. You can say this pod has the tag application, I don't know, pocket calculator, environment, test, developer, XYZ. You can just add arbitrary key value pairs. And then if you, for instance, add a load balancer, a network element that makes your pod available on the internet, or an Ingress controller, you do not say, go to this IP address, because there are no IP addresses in Kubernetes. It's always changing. New servers come in, new servers come out, and so on. IP address wouldn't work. What you use instead is so-called selectors. You say, hey, if a network request comes in on this load balancer, Ingress Controller service, then forward it to a pod that has the following properties. Look for the application pocket calculator, look for the test environment, and look for the version of developer XYZ. So the selectors are the routings inside the Kubernetes cluster. That is super powerful. That means you can delete the pod, then the service is no longer available, and then you can spin up another pod with the same properties, and the routing will be fixed again. Understand what I mean? That is meant with labels and selectors. Of course, you can also use it for organizing. This is what I wanted to tell you. Okay. If you want to take a closer look here, just look for label selectors. It's really an art form of itself. We will have them very simple, but I will show you when we do the demos in a few minutes. I will always point your attention to the label selectors. Good. Nice. With that, let's have some fun and run applications in Kubernetes. If you want to run applications in Kubernetes, you have to install a bunch of client tools. First, kubectl. We discussed that before. Please take a look, Google for it, install it if you haven't already installed it. Many of you have installed it. Awesome. There is a description for our school's Kubernetes cluster. You can find the link here. I recommend using the WSL, the Windows Subsystem for Linux, if you run a Windows computer. And I have two tips for you. First, I encourage you to give the auto-completion a try. There is a description what you can do, and that gives you auto-completion in the console. Let me show you what that means. I go here into the console. I say kubectl get pods, and here we have our API demo pod. And see what I do now. Kubectl describe pod API, and now I press tab. So that's statement completion. So I get completion for all the difficult names and so on by just pressing tab. And the link here that you can find in my slides exactly here describes how to set up auto-completion in the shell. It's so useful. It's really so useful. I can really encourage you to do that. Additionally, if you find that typing this kubectl get pods and so on is really tedious, then you can install a nice little collection of aliases. You see there are many aliases. And if we quickly take a look, then you see there is, for instance, an alias for kubectl get. See? Follow the link here. I thought I set it up correctly yesterday, but I obviously made a mistake. Essentially, that makes it shorter. You don't have to type so much. If you don't care about typing, that's fine, but this is a useful tool. Next one. If you are not so much into typing, and if you find it complex to set up your kubectl proxy to access the dashboard, I have good news for you. Because you can install and add in to your Visual Studio Code. I will reinstall it. There is a plugin in Visual Studio Code that gives you nice little view to Kubernetes. And now let me zoom in a little bit. In this case, the Decker desktop is recognized automatically, and I should be able to add an existing cluster. It's really nice because you can do everything graphically. So for local development, that's really useful. Yeah, some examples of getting a Kubernetes cluster. You can use our school's Kubernetes cluster. You can install Docker Desktop. You can use your Azure benefits. You know, you have this $100 per year Azure benefits. So you can spin up a managed Kubernetes cluster within a few minutes. But be aware, running a Kubernetes cluster in Azure eats up your benefits pretty quickly. So only start the Kubernetes cluster if you really want to play with it, and undeploy it when you're done. Otherwise, the $100 are away within a few days or weeks. So that is important. Let's try a bunch of things. First, let's simply start a web server on our Kubernetes cluster. For that, for those of you who would like to follow along, you don't need to type in the statements. They are on slide 19. Everybody else, just take a look and try to follow mentally, and then we can try together. The first statement that I would like to introduce you to is kubectl run. It's like Docker run. You specify the name of the image, for instance Alpine, in order to run an Alpine web server. Oh, sorry. That's here with image. It already says Alpine. And you specify the port that is published by this container. If you hit enter, the pod is created. That creates a pod. So if I say kubectl get all, for instance, I will see that I now have a pod Angelic running. It has been running for 7 seconds. That's kubectl run. It's like Docker run, but on the Kubernetes cluster. With kubectl get pods, of course, you can take a look at all the pods. What if I want to run not a web server, but what if I simply want to run a small Linux server where I can interactively type in things? Absolutely no problem. For that, you use kubectl run, but you use, as you can see it here, -it, interactive and terminal. Then you specify an image, in this case I say Debian, and you press enter. That will spin up a Linux machine, a Debian machine, inside of your Kubernetes cluster, and now you can have fun with it. This is a Debian Linux freshly installed inside of the Kubernetes cluster. Ad hoc, we can do everything directly from our machine. That's pretty awesome. We don't need Linux anymore on our machines. If we have kubectl and you have a Windows machine, you can simply run your Linux shell directly in the Kubernetes cluster. Do you understand what we are doing here? And that's pretty interesting. And if you say exit, it's gone. Please note that I used here the switch --rm, rm like remove, and that means when I exit the Kubernetes pod, the pod is automatically destroyed. So I don't need to delete it manually. So the first demo was running a web server. The second demo was running an interactive terminal. If I want to learn about details about one of my pods, I can use kubectl describe. Let's make it a little bit smaller. Kubectl describe gives us, let me scroll up a little bit so you see it better. Where is it? Where is it? Where is it? Here it is. Gives us a lot of detailed information about the pod. It tells us the IP address, that's the internal IP address of the node. It tells us some events that happened. So, looks good. Describe. Describe not just works with pods, describe works with everything. Whatever you create, a pod, a deployment, a service, a replica group, you can always say describe to see details. This is not that important, this is not that important. And I already showed you how you can access the web server with the port forwarding. We have to delete the pod. Kubectl delete pod Angelic. And you see, it's gone. Pod Angelic deleted. If we say kubectl get all, we will see that everything is clean again. The only thing that is still running is this one, the pod here. So I can take this one and again say kubectl delete pod this one. And the pod is gone. Pretty simple, pretty straightforward, isn't it? Kubectl get, kubectl run, kubectl delete, and we're good. Port forwarding, we also did port forwarding, so I think we are good. Any questions regarding these things? Now I have the good news. You don't need to remember any of these statements. Why? Because this is just for beginners. And hey, we are not beginners, right? We will now learn how the pros use Kubernetes. Because professional Kubernetes developers, They will not interactively run pods and delete pods and things like that, but they will write manifest files. They will write YAML files where they specify what they want to do in order to consistently being able to repeat things. Just like a Docker file is a recipe for building an image, a Docker manifest file, a YAML file, is a recipe for starting pods, starting services, starting deployments, and removing those things. So essentially we will write text files and then we will run these text files as scripts to perform certain actions on our Kubernetes cluster. The statements that you saw before are nice for playing around, for interactive development, for learning, for exploring the cluster, but for real development work, we will specify these manifest files, these scripts that automate our Kubernetes stuff. And this is exactly what we are going to do. Now the next demos that we will work together are part of my GitHub repository. Let me show you where you can find it. In my GitHub repository that I gave you for the slides, you will find a folder here on the Docker demos, and there you find something that is called 13 Cube Intro. And there you will find a bunch of demos that we will now work through together. Okay? The first demo that we are going to take a look is this one, the Angelic pod demo. If you would like to follow along, I ask you to clone this repository onto your local machine. So you fetch the URL, you do a git clone, so you have the demos on your local machine. I already did that. And I have it here. See? So please, I give you a second. Go into this GitHub repository, clone the GitHub repository onto your local machine, and then navigate into this folder. Once you have it, please start Visual Studio Code inside of this folder. Ah, see? Now it's good. Yes, awesome. Okay, here see the samples. And I ask you to open the first YAML file here and 01 pod sample. Let's take a look at this manifest. That's a typical, I would say, simplified but reasonably sane manifest file for Kubernetes. You see, we say, I want to create a pod. I give the pod a name. Then we have labels. Can you remember what we need labels for? In order to connect services between each other. That's the name value pair stuff. Then we tell the system that our pod contains a single container. Here you see the container. It should be based on the image Angelic. It has the port 80 and it listens on the TCP protocol. Really simple. If you want, you can use the Alpine image. That is even faster. And now comes the beautiful thing. Watch me what I do and then you can try it. You navigate into the folder where you have this YAML file and then you simply say kubectl apply -f like file dot. Dot is the folder. And now kubectl will walk the whole folder through, look for all YAML files, and execute these YAML files against the Kubernetes cluster. Enter. Done. See? Pod created. And that's the idea. This is how you should work with your Kubernetes cluster. You should specify in files, in these YAML files, what you want to do. And then you check in these files together with your source code. Just like you check in the Docker file. You check in this YAML file. And then everybody who consumes your project on his or her Kubernetes cluster can simply say kubectl apply, and they will deploy the pods, and everything will spin up just as we expected. Do you understand what I mean? Yes, question.
Wie kommen wir in das, wie kann das Repository von Ihnen auf eine PSL-Klon?
Git-Clone?
Ja, aber ich weiß nicht, ich bin gerade nicht mehr sicher, wie der hinkommt zu dem Ordner, ich weiß nicht, wo der gespeichert ist.
No.
Okay.
Ja, genau.
Okay. There is a question regarding WSL. If you start a new WSL, you are automatically, typically, in a subfolder of MNTC, in a Windows mount. I will strongly encourage you to not store your files there. Not do a git clone on a Windows mount. Instead, go to your user's home directory, for instance.
Oh, yeah.
And there you can, for instance, create a subfolder which you could call GitHub. In my case, it's called GitHub. Inside of this folder, I do git clone. And then I have my cloned repository inside of my Windows subsystem for Linux, in the Linux file system, not in the Windows file system. Nevertheless, listen closely, that's important. I can still say explorer.exe. That will now magically run the Windows Explorer connected to my Linux file system, and I can maintain my Linux file system graphically in my Windows File Explorer. Isn't that cool? I love that. Additionally, I can also say code dot. That will spin up Visual Studio Code connected to my Linux engine, and I can graphically navigate the folder structure, and I can also start a terminal which will be automatically in the correct folder in the Linux machine. This is why I love the Windows subsystem for Linux. It gives me really the best of both worlds. It gives me the graphical user interface of Windows, which is tightly and seamlessly integrated with my Ubuntu machine, in this case, through the WSL. But still, if you want to work in Linux, I encourage you to not clone in a Windows mount, but clone in the Linux file system, and then work with the Linux file system in a way that I showed you now.
Okay.
Yeah? Working like that is not even possible on Mac, although Mac is a little bit nearer to Linux than. So with that, I hope you are able to open Visual Studio Code and to go into the folder and apply it. And now if we say kubectl get pods, we will see that our pod, Angelic pod, is running. Nice. If we want to delete everything that we just deployed, we don't need to remember all the things that we deploy. We can just say kubectl delete -f dot, and it will remove all the things which are defined inside of that folder. Imagine your application consists of a backend API, a second API, a container with a single page app in Angular, for instance, and you would like to spin everything up, and when you're done, you would like to spin everything down again. Kubectl apply to spin everything up, kubectl delete to remove everything. Understood? There is one project that we will not take a close look at, but I would like to at least mention it. That's the Helm Project. Have you heard of the Helm Project? Very widely used, very well known. Everybody's talking about Helm when going through Kubernetes. It's a package manager for Kubernetes. It's like NPM for Kubernetes. It's like nougat for Kubernetes. Imagine that you read a blog article and somebody says, there is this super cool app, and you think, I would like to have this app on my Kubernetes cluster. Isn't it boring that you have to go to GitHub, clone all these files, go into the correct folder, run kubectl apply? That's very tedious. Helm simplifies that. You simply say Helm install name of the app, press enter, and it will fetch down all the things it needs. It will fetch down all the Docker images. It will spin up all the deployment services, Ingress controllers, whatever you want, and your app runs with a single line of code inside of your Kubernetes cluster. That is Helm. So if you build your diploma thesis with Kubernetes, you might consider at some point, maybe at the end of the work of your diploma thesis, you might want to consider creating a Helm chart. It's called a chart. It's just a script that describes how to install your app on a fresh Kubernetes cluster. Because if Mr. Abiaga, for instance, decides to reinstall our school's Kubernetes cluster, and suddenly you cannot demonstrate your app anymore because it's gone, wouldn't it be super convenient if you just connect to the kubectl, say Helm install, and your app is up and running again within seconds? That is the idea of Helm charts. Got it? Question?
The effect will happen in the summer. It's all done.
Yes, correct it. Exactly. And then Helm charts would be really, really useful. Helm charts is, for instance, an addition that Microsoft made, primarily Microsoft made to the Kubernetes ecosystem. It's managed, or some of the core contributors are working for Microsoft. We had one of them in our Rust meetup a few weeks ago. Okay, good. Nice. So we are now capable of running pods using kubectl apply with a manifest file. Next one, next example. The next example is a service. Let's take a look at the manifest file. The first one, the pod file, it's really exactly the same as before. We run a pod, by now you know what a pod is, with a certain name and some labels. Again, for sake of simplicity, we just run Nginx Alpine. But please use your imagination. It would not be different if you run your web API here. Just the name of the image would be different. Everything else would be exactly the same. So it's fine if we do it with this simple demo here. And now comes the important one. Here we have the service. The service, in this case a node port, makes our pod available on all nodes of our Kubernetes cluster. And we can also do, as you can see it here, some port mapping. And here you see the selector. Let me show you what that is doing. Up here, you see that you have this label app workshop. See it here? That's a label. Here, we say this is the selector workshop. And this is how these two things play together. See it? I could run 3 different pods, all with the name, with the label app workshop. And then the service will distribute the load across all these pods. Because it will simply look up all the pods which fulfill this selector requirement. And in this case, it just says app workshop. Of course, in real life, these selectors are way more difficult. Maybe in your case, it's called, I don't know, backend, or backend for frontend, and whatever you want to call it. Understood? Your namespace is always implicitly part of the selector. So you don't need to care whether your colleague also creates a pod with app workshop. It will look up the pod inside of your namespace. So Mr. Abiaga has set everything up in a way that every one of you has a kind of private sandbox inside of this Kubernetes cluster. Understood? Good. Let's give it a try. Go into the second folder. kubectl apply -f dot. And this is the point. This is the important one. Come on, where is it? Here. In this folder, I have two files. And kubectl apply automatically recognized that there are two files, and it created both artifacts in Kubernetes. So now I have a service. The service makes my API available on all cluster nodes, and it will redirect the traffic internally to the to the node where my pod runs. I will repeat that because it's kind of difficult to understand. Maybe we have 3 servers. My pod is running on server A. Here is my pod running. But I'm trying to access my application, and I access the IP address of this node here. But my pod is running here. The service node port makes it possible that we can reach our pod, which runs here, through this node. Because it routes the traffic internally and automatically finds the pod on the correct node. This is what a node port service does. Understood? Good. It's not that super useful. I mean, yes, it is super useful. But for our purposes, maybe you are thinking, is this really what I want? Well, probably not. Wait a few more moments and I will show you a special kind of infrastructure which is called Ingress Controller, and then it becomes really interesting for you. For now, it's good. If you would like, you can say kubectl get all, and you will definitely see that you have here the service and here the pod, and you can get rid of everything by saying kubectl delete -f dot, and it will remove the service and the pod. Before we go into the break, let me quickly show you an example that Professor Aberger created. Sorry, I wanted to click on Get Started. Exactly. And I wanted to show you, where is it? K8s, here it is. For instance, here I wanted to show you the WAML file that Professor Aberger created for his sample application. You can take a look at it. You will now recognize things like deployment. We have talked about deployment. If I scroll down, another deployment. If I scroll down, we will see a service, you see? But the important thing that I wanted to show you here is this one. If you don't like to have multiple separated files in a folder, you can add multiple Kubernetes objects in a single file and separate the objects by 3 dashes. It's really up to you. You can have 10 files, or you can have a single file with these dashes in the middle. That depends on your personal style and preferences. It's just like in C#. You can write multiple classes in a single file, or you can use a separate file for each class. Both work well, you have to decide. Got it? So it really depends. It's completely up to you. The examples that Mr. Aberger created are really great. If you want to get deeper into the HTL Leonding cloud, definitely check them out. So you have now seen how we can do a service sample. When will the break start? I think at...
4 minutes.
Pardon?
In 4 minutes.
4 minutes, awesome. Then we can do the last demo, and that might be interesting. Because now we will put stress on the HTL Leonding cloud. Should we? Yes, we should. Because now we are going. Please don't be. Please don't be destructive. Okay, I will show you now what we are going to do. Okay, this will run a deployment, and as part of the deployment, we will have a replica set. See that one? So we can not just create a single pod, but we can, with one single statement, create 5 pods. And I ask you to not write here 999 pods. Please do not, okay? Use a value between 3 and 5 or something like this. Let's try it, okay? Let me show it to you and then you can try it. And let's see, let's see how the HTL Leo cloud will react. So let's go to the sample 3. This is the sample 3 with deployment sample, okay? And there I say kubectl. Just check it out on my screen, then you can try it on your own. Apply-f dot. Okay? Kubectl, come on, kubectl get pods. And if we are lucky, yes, all 5 are running, you see? If I undeploy it, kubectl delete -f dot, and if I'm fast enough, terminating, you see? Terminating, 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 2 are terminating, done. So, now we can try the following. I don't know, use 5 instances or something like this. And now we all run it at the same time, okay? We'll spin up a lot of pods now. So I will start it now. And now we do everything, and you told me that the HTL Leonding cloud sometimes crashes under load. So now we are really placing load on it. And if you take a look, it's already done. So that's pretty awesome. It's really not bad. And you see, can you remember what I told you about desired state and current state? Our desired state is 5. Our current state is here 5. You see it? And now we change the desired state. I simply say 3 are enough. If I do that, and I just say kubectl apply again. See that one? So I change the desired state. Let's run it. And if I'm fast enough, I will see that 2 are terminating, you see? But the other 3 keep running. And now you should understand what I mean with desired state and current state. I can tell Kubernetes to aim for a different desired state, and it will automatically figure out what to do and spin up pods or destroy pods depending on what I did. Got it? Understood? And we didn't crash the HTL Leonding cloud. Woo! Very good. I like that. Good. We now have a break before we go into the last hour. Yeah, let's do a break.